Hi everybody, Marty Geyer back again for gsp295, I'm sorry. And today we're going to talk about Big O. Now this is a really complicated concept, but also a very, very, very important one. We're going to talk about it throughout the course. There will be questions on every quiz, final exam. In other words, it's pervasive, and it's something you really need to know about, and something that's going to guide us through the course. And that's why we attacked it in week one. But it is a very tough conceptual thing, and it's heavily based in mathematics. So please try to follow through here with my mathematical explanations. But if you're not completely understanding, it's not a huge deal. I don't want you to think you have to have a master's degree in math in order to understand this stuff, because you don't. Really, the end result is what's important. And there's a couple of, hopefully, what I hope is simple examples will help you get through this, and that's really the intent here. Your book doesn't touch this topic all that well, only a couple pages, and what it does say is a very good example and introduction, but I want to give you a little more, especially because the course is really going to hit on this, and the book probably doesn't give you enough here. We participate in the discussions too, where we're going to get pretty fancy and get in more detail there. A lot of topics in this course are kind of brushed on in the book, but they require a little more web research and a little more explanation and discussion, and that's why we have discussions, lectures, and book reading, so that you can have everything all together in one big experience and get all the information you need. So, another shameless plug for all the different modalities of the course. They're all actually important. So please do use them. So let me try, the toughest part of this is just getting started and explaining what this is and represents. So what Big O is it's a classification of the runtime of a particular program, a particular algorithm or segment of code usually, and that leads more to the runtime of the entire program and to an entire, or to an entire algorithm first, and then to an entire program, because programs are usually made up of algorithms, or they're driven by the runtime of their algorithms. So it all comes down to a segment of code. So let's take a simple example here. Here you have a scribbled for loop, and this is why I don't write code on a whiteboard, because you can probably barely read this, but basically this is a for loop for I equals 0 to n, I++, and a simple cout with hi. And so this extremely useless piece of code will simply loop over till n times and print hi n times, right? Hi, 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 hi. I'm sure we've all written a program like this before, whether it was intentional or not, many times unintentional. But hi is fun, so that's why we started here. So what's going on here is important to realize that you start with 0, you do this n times, right, for the number of presumably the number of inputs. So there's a function level up here that I've omitted, which will take an input n, and then do this for n number of times, and I is just a looping variable that tracks which particular time you're on. So it's kind of easy to see from a simple example like this. Since this is doing this n times, then the runtime of this whole segment of code is driven by n. That is, whatever value you pass in, if you pass in 2, then it's going to print this 2 times. If you pass in 4, it's going to print it 4 times. You pass in 2,677,000, and I'm not going to remember that number the second time, then it's going to print it 2,677,000, blah, 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 that many times. So what we have here is a function driven entirely by n. And that's why this is a big O of n segment of code. And if this was an algorithm, or assume this is our algorithm, even though it's a really silly algorithm, then that would make our algorithm big O of n. And if this was our whole program, that we simply pull n off a command line or ask the user, please enter a value of n. And enter a value of n, hit enter, then we go through this loop, then the whole program would be driven by n. Now, let's start with that. Now, notice there are other segments of code. If this for loop wasn't here, and you just simply had the cout statement, that this would be not dependent on n at all, right? Even if we asked, please enter a value of n, you enter a value of n, and now we just cout hi, we don't care what the value of n is. Even if we cout the value of n, you could say hi, and then change this to n, cout 4, cout 5. The runtime is still just one. One statement is executed. That's it. So even though we ask for a number, well, if we're asking for a number, then we actually execute 4 statements or 3 statements. please give me a number, input the number, C out. So it's 2, 3, 4 statements. We'll get to that, hold that thought for just 1 second. But it's not based on n. If we enter a value of n of 2 million, it doesn't mean we execute 2 million statements. We just simply print the value of n, or print high, once. That's all we're going to do. If this for loop, again, was not here, we're pretending. Now, it doesn't really matter if there's 1 statement, or 2 statements, or 3 statements, or 4 statements, or even, I don't know, 1,000 statements that are written around this, like input-output statements and things like that. They don't drive the algorithm. And the reason why is they don't depend on n. So no matter what value of n is passed into any particular function, with couts and cn's and all that stuff, it doesn't change the fact that you go through the same number of lines. But loops do, notice, because loops are dependent on n. Anytime you go through any kind of loop, doesn't have to just be for with anything, then you're going to repeat based on n. So big O is a way of, I want to say, mathematically waving your hand at problems to categorize them in a general category. So we don't have big O of 4. Why not? Because we don't care, right? If there's 4 statements and it doesn't depend on n, then we just say it's O of 1, which isn't written up here, but should be. So O of 1, right down there, is simply going to be 1, no matter what. And this basically means constant time, not dependent on n. And that's always the best time to have. So if you have a program that simply has a bunch of CNs and couts, you have no algorithm, you have no order runtime, it's just O of 1. Now, if there's 4 or 5 statements, it doesn't matter because we're going to categorize it in that 1 column. If we have it dependent on n at all, then it depends on what value of n the algorithm is. We'll get there in 1 second.